Welcome to aminacademy.com. Let us discuss about a taste of quantum mechanics. The physics describing the world we experience every day is referred to as classical physics. It describes how large objects, that is, objects made of billions and billions of atoms, interact with each other, whether it is the motion of the planets in our solar system, the behavior of a car when you accelerate, what happens when you play billiards, or how electronic circuit work. Classical physics is a set of rules that were discovered and quantified by the likes of Galileo, Newtons, and many others. Classical physics is a tremendously successful theory of nature and has led to astonishing human feats. We put a man on the moon, built bridges, skyscrapers, supersonic jets, developed wireless communications, etc. The fascinating part of is that classical physics is not the ultimate description of nature. There is much more to reality than what we see and experience. If we try to describe the behavior of atom and their constituents, for example, protons, neutrons, electrons, using the laws of classical physics, completely fails. Actually, if we describe the motion of electrons around the nucleus of an atom using classical principles, you can calculate that any atom would collapse within a tiny fraction of a second. Obviously, the world we live in is made of stable atoms. So, what's going on? Well, it turns out that classical physics is only an approximation of physics that work for large objects. In order to describe a behavior of the building blocks of nature, we need to radically different approach that, as you will learn, leads to surprising and fascinating new phenomena. Welcome to the beautiful world of quantum mechanics. Particles behave like waves and waves like behave particles. Electrons tunnel through barriers. It's impossible to perform a measurement without perturbing the environment. Entangled photons are so strongly interconnected that they behave as one no matter how far apart they are. These are all part of the everyday life in the quantum world. Quantum mechanics can be baffling, yes, surprisingly, definitely, and certainly counterintuitive. That's because quantum mechanics lives outside of our everyday lives, and any attempt to explain quantum phenomena using classical physics fails. Quantum mechanics just is, and it's awesome. Turns out that quantum mechanics is not really that complicated. We just need to experience it and build a intuition about it. Quantum mechanics opens a door to a world that may surprise you, a world where the rules of the game are different, much different. Developed in the first half of the 20th century by the scientists of Max Planck, Erwin Schrödinger, Werner Heisenberg, Paul Dirac, and many others, the theory of quantum mechanics, also called quantum theory, never ceases to amaze us, even to this day. At the time, quantum mechanics was revolutionary and controversial. Even a genius like Albert Einstein thought it could not be a serious theory. Unfortunately for him, he was wrong. An astonishing amount of experiments have been performed in the last few decades demonstrating the validity of quantum theory. As a matter of fact, we can safely claim that quantum theory is the most accurate theory were developed by mankind. Every attempt to prove it wrong has failed miserably. You may have already heard about wave particles duality. It's one of the most quintessential phenomena of quantum. Sometimes an electron or any other quantum object behaves like a particle, sometimes it behaves like a wave. How do you know when you should treat the electrons like a wave and when you should treat it like a particle? Part of the beauty of quantum mechanics is that we don't need to make the distinctions, it's all contained within the theory. Finally, note not only does quantum mechanics accurately describe the behavior of atoms and molecules, it can actually describe nature at any scale. The only reason we don't really need quantum mechanics to describe large objects is because the quantum effects play such a small role that they can be ignored. And classical physics represents an accurate approximation. Quantum technology, quantum mechanics has already had a tremendous impact on our lives. Not only does it tell us how the world behaves at its core, at the atomic level and beyond, but it has led to transformative technologies that have shaped and continue to shape in 20th and 21st centuries. The laser, LEDs, magnetic resonance, imaging MRI, transistors, and so much more all exist because the worlds behave according to the rules of quantum mechanics. Now let us discuss further detail, interesting detail about a taste of quantum mechanics. Quantum mechanics. Quantum mechanics is the physics of every small explaining that tiny objects like particles can act as both waves and particles, a concept called wave particles duality. This field includes principles like superposition, being in multiple states at once, Heisenberg's uncertainty principles, the limit on knowing certain properties simultaneously, and entanglement, spooky action at a distance. These concepts are essential to modern technologies like lasers and GPS, atomic clocks, etc. Key concept to grasp wave particles duality. Tiny objects like electrons can behave like both discrete particles and spread out waves. Superposition. What is superposition? A quantum objects can exist in multiple states at the same time until it is measured. The quantum superposition is a foundational principle of quantum mechanics that states a quantum system like an electron or photon can exist in multiple possible states at the same time. This is fundamentally different from classical physics where an object can only be in one state at a time. The system the system's state is not a mix or an average possibilities but a combination of all of them at once. This bizarre This bizarre behaves is only observable in the microscopic quantum world. In our macroscopic world, any superpositions collapse instantly when measured, forcing the system into a single definite state. Uncertainty principle. There is a fundamental limit to how precisely you can know certain pairs of properties such as particles, positions, and momentum at the same time. These are uncertainty principles basic. The uncertainty principle is a fundamental concept in quantum mechanics stating that you can't simultaneously know with perfect accuracy certain pairs of physical properties like a particle's motion and momentum. The more precisely you measure one property, it is a position, the less precisely you you know, you can know the other. That is, for example, momentum and vice versa. This is not a limitation of measurement tools, but an intrinsic property of quantum system. The, the entanglement, the two or more quantum particles can become linked in such a way that they share the same fate, even when separated by large distances. Measuring one instantly affects the other. Observer effect. The act of measurements itself can disturb a quantum system, meaning a human observer is an unavoidable part of the theory. Why it's important? Explain the world around us. It governs the behavior of atom and molecules, which is the basis for all matter we interact with, including our ability to see, smell, and touch things. Quantum mechanics is a fundamental theory that explains the behavior of matter and energy at the atomic and subatomic level, revealing the underlying principles that govern the world around us. It replaces classical physics that with new and often counterintuitive rules that are essential for understanding everything from chemical reactions to the technology we use every day. Drives modern technologies. Quantum mechanics is the foundation for technologies such as lasers, atomic clock used in GPS, and the overlapping field of quantum computing. Quantum mechanics is the foundational theory that underpins countless modern technologies by describing the behavior of matter and energy at the atomic and subatomic levels. Technologies built on quantum principles include lasers, semiconductors, and medical imaging devices. The ongoing second quantum revolution is now exploiting more exotic quantum phenomena to develop entirely new technologies such as quantum computing and ultra secure communication. What is quantum physics? Finally, we talk about what is quantum physics and what makes it so rare. We will introduce key aspects of quantum physics with an aim to explain why it differs from everyday classical physics. Quantum enabled devices like the laser and atomic clocks for GPS will be explained. We will also discuss the breakthroughs driving the second quantum technology revolution surrounding quantum simulators, sensors, and computers. Seminars discussion and laser lab will help illustrate core principles, including the atomic clock mechanism. Visits the campus laboratories will introduce cutting-edge quantum experiments. This InfoSem is designed for those likely to go to major and the humanities or in STEM program outside of the natural science. So far we discussed detail about the taste of quantum mechanics. If you have done, please subscribe our YouTube channel.